What is DC motors? DC motors are electric motors that convert direct current DC electrical energy into mechanical energy. They are widely used in various applications due to their simplicity, ease of control, and reliability. Here's an in-depth look at the different types of DC motors, their constructions, and operation. Working principles. In a DC, the magnetic field is created by either permanent magnets or electromagnets, while current flows through the armature windings, generating a force perpendicular to the magnetic field. The commutator and brushes ensure that the current direct in the armature windings reverse every half turns, maintaining unidirectional torque. This result is continuous rotation of the armature. Additionally, the rotating armature generates a back EMF which oppose the applied voltage and establish the motor speed. So they have four types of DC motors. Number 1, shunt wound DC motors. 2, series wound DC motors. 3, compound wound DC motors. 4, permanent magnet DC motor. What is shunt wound DC motors? A shunt wound DC motors is a type of DC motors where the field windings is connected in parallel with the armature windings. Because of this connection, the motor maintains a nearly constant speed even when the load changes. It has good speed regulation and moderate starting torque, which make it suitable for applications such as lattice, fans, blowers, and conveyors where constant speed is required. Number 2, series wound DC motors. A series wound DC motors is a DC motors in which the field windings is connected in series with the armature windings, so the same current flow through both. This motor produces a very high starting torque, making it ideal for heavy load applications. However, its speed varies greatly with load and can become dangerous high when there is no load. It is commonly used in electric trains, cranes, hoists, and elevators. Number 3, compound wound DC motors. A compound wound DC motors combines the characteristic of both shunt and series wound motors because it has both shunt and series field windings. This design provides good starting torque and relatively stable speed under varying loads. Compound motors are often used in applications that require both strong starting power and good speed regulation, such as presses, rolling mills, and heavy machinery. Number 4, permanent magnet DC motors. A permanent magnet DC motors (PMDC) use permanent magnets instead of field windings to produce the magnetic field. Because it does not require field coils, the motor is smaller, lighter, and more energy efficient. It also has a simple construction and low maintenance requirements. EM motors are commonly used in small devices such as electric fans, toys, power tools, and automotive accessories like windshield wipers. So let's proceed on construction of DC motors. Number 1, yoke and poles. 2, armature assembly. 3, commutators and brushes. 4, shaft and bearings. 5, electrical connections. So yoke and poles. The yoke is typically cast as a single piece or assembled from steel plates. The poles are mounted on the yoke, either bolted or welded, and the field windings are wound around the poles. And number 2, armature assembly. The armature core is constructed by extracting limited steel sheets to form a cylindrical structure. Armature windings are inserted into the slots of the limited core and connected to the commutator segment. Number 3, commutator and brushes. The commutator is assembled from copper segments and mounted on the shaft insulated from the shaft and each other. Brushes and held in place by brush holders and spring loaded to maintain contact with the commutator. Shaft and bearings. The armature assembly is mounted on the shaft, which is then placed into the bearings fitted in the end covers. The end covers are attached to the yoke, completing the mechanical assembly. Last one, electrical connections. The field windings are connected to the external power source either in parallel shunt motors or in series motors with the armature windings. The armature windings are connected through the commutators and brushes to the external circuit. So here's the example of generators, and you can see the photos of generators, and here's the and why generators is generate. And I think that's all, and thank you once again.